Gosh. So let me see. Let me make it all about me. Bam. You guys okay out there? Anybody have any questions from homework stuff? Any questions about anything? When's the next quiz?
Monday.
Monday. I love it. And if you notice, I've changed the due dates for chapter 3 assignments. So you can kind of pay attention to those. Does anyone questions from anything?
So we don't have class tomorrow, correct?
That's right.
Okay, just checking. Thank you.
Yeah, tomorrow I'm going to be, thankfully, not the only presenter, but I am presenting at a statewide conference thing. So that should be exciting. It's a fantastically quick way to embarrass yourself in front of thousands of people across the state. It's going to be great. Okay. All right. So everybody's good. That's what I'm going to go with. Okay. All right. So last time we talked about section 3.4, which was all about inequalities and how to solve them. Can somebody remind me what's the one thing about solving inequalities that you have to be careful about that's different from solving equations? Is there anything different?
Yeah, when we divide or multiply, we want to switch the greater to more than and the opposite.
Yeah, when you divide or multiply by what exactly?
Minus.
Good. When you divide or multiply by a negative,
Negative, yes.
you have to switch the sign. I like it. So, real quick. This is on page 332 if you've got your book. Can you guys do the first two here? Should be very quick, very nice. Just these first two right here. So solve it, graph it, and then even check it if you remember how to. It kind of tells you how to right here. Solve it, graph it, check it, bop it, turn it, twist it. So this first one should be crazy fast, right? How do I solve this first one? What do I do?
You're dividing 2 on both sides.
Good. Divide by 2. So I can kill that stupid 2. So I get x. Do I switch the sign?
No.
Hell no. I didn't divide or multiply by a negative. X less than 5.
And so it's an open circle.
Good. Okay. You get
And
an open circle.
it goes to the negative.
Good. So it's pointing you this way. Where are the x's less than 5? They would be on this side of 5. So I'm going to shade in.
And then it would be negative. And would it be a bracket or a parentheses on this?
Are you talking about for interval notation?
Yeah, my bad. Sorry, am I going ahead?
Yeah. I don't think this book goes that far, but I don't know if anybody remembers something that looks like this.
So I have flashbacks and I get sweats when I see this. It just starts math class Achilles heel.
Goes from the smallest to the biggest. So how would you define the shaded part for somebody? Well, it goes from negative infinity, because it goes forever, up to 5. And it's a parenthesis because I don't include the 5. And I always would put a parenthesis on infinity because you can never get to infinity. If you put a bracket on infinity, then I want you to bring infinity to me. My theory about Pulp Fiction is that is what was in the suitcase. But I don't know if you've seen Pulp.
And
Yes.
instead the empty circle, we can say parentheses, right?
Oh yeah, exactly. So you
Okay.
could use this symbol instead. Don't worry about this. This was just a little side conversation, right? I don't know if that looks familiar to anybody.
This might be the time to move
Sorry?
all.
What's up? Tristan, did you know you're
Yeah, sorry, I was talking to my girlfriend about something. Sorry.
all right. So now what about this guy? Oh, wait, to check this, does somebody remember how I could possibly try to check this? How many answers are there?
Yes, we can put 2 times 5.
No.
There's infinite answers, right?
Why can't I do 2 times 5? Is 5 a part of the answers?
No, because it's not equal to that.
Good. It's not
No.
equal to 5.
No,
So
no,
you
no.
you could pick.
Yeah,
So give me
can
one
any number.
that's answer.
Yes, yes.
Give me one
Yeah.
number that's an answer.
4.
4. I love it. So if you put 2 times 4, is that less than 10? Check.
Yes.
And the check that we do for these is less specific. You could actually still be wrong, but at least I feel a little better because 8 is less than 10. So that at least that much checks out. All right, let me stop for a minute. Nothing major there. Go ahead and finish this one up if you're still working on that one. All right, guys. So what would I do first? Somebody else tell me. What would I do first here?
Divide the -3.
I love it. So then what do you get as a result?
You would flip the sign and it would be -4.
Kick ass. I got to flip the sign because we divided by a negative. I like it. So then I put my -4 down.
It'd be a closed circle and it'd go to the right.
Good. I would shade in the direction of the answers. And is -4 an answer? Yes. So I would shade it also. That is the idea of a closed circle. I shade where the answers are. What else could you put on the -4 instead?
Bracket.
Bracket. You could have put a bracket there instead if you want to. So it would look like this. Bracket. Right. So these are Goku's hands. I'll stop. All right.
Professor, you said the reason why you shaded it is because it's negative?
No, the reason why I shade shade the circle
Yes.
is because it's allowed to equal -4.
Okay.
Yeah. So here is 5 an answer? No, so I'm not going to shade it. It's just an empty circle on 5 because 5 is not a part of the answers. It's not allowed to equal 5. This has a little equal sign, so that means I'm going to shade it in because it's allowed. Yep, I like it. Now to check it, somebody give me any of the infinite numbers that are in here. Give me a number. That's supposed to be an answer. All right. There's a
-3.
oh man. Where's -3 at? Where's 0 on this number line? Is it back here, up there? Where's 0?
It's in front of it.
Yeah, it's over here. So where's -3?
Oh, it's behind the -4.
Yeah, poor little -3. He didn't make it in there. Meh.
You can say -5 or 6 and bigger.
-5. I love
Smaller,
it.
yeah.
Let's do -5. So -3 times -5, is that bigger than or equal to 12? Is 15 bigger than or equal to 12? Yes or no? Is 15 bigger than or equal to 12?
Yes.
Yes. So it works. All right. You could have used -4, couldn't you? Because that is an answer. But you know, anything that's in there works. All right, let me stop for a minute. All right, so do this one real quick and then we're going to move on. Do that one down here. All right, somebody help me out here. What's going to be the thing I do? What's the first thing I do here to solve for t? Why is t not by itself?
Would you times it by 4/1?
Yes. So yeah, I like it. You can think of it as multiplied by the reciprocal, or even just, isn't this t divided by 4 basically? So then wouldn't you multiply by 4 to cancel the division by 4, right? Are you guys out there? Are you guys doing okay?
Yes, sir.
Are you getting tired of just asking you that? And let me tell you, teachers are getting tired of asking that. I understand. So then you multiply by 4, multiply by 4. Now somebody else tell me, what do you have left? What do you get?
T.
Sure. And?
Greater than.
Greater than. Why do we not flip this sign?
Because you're not
No.
dividing.
Yeah, what did we multiply by?
Four.
Positive 4. No worries. Don't say, oh, there's a negative. Oh, no, I don't give a shit if there's a negative somewhere. What did we do? We multiplied by 4. We did not multiply by negative. We did not divide by negative. So that sign does not switch. There's -12.
Oh, okay. So it only flips whenever you multiply by a negative.
Exactly.
Is that what you're saying? Okay.
So watch this. Watch this. On a little side note. Which one of these is bigger? Anybody? Which one of these is bigger?
The +3.
Holy shit. Yes. So 3 is bigger than -1, right? Now, if I multiply both sides by 4, you're going to multiply both sides by 4. Cool. I get -4 and 12. Which one's bigger?
The 12.
The 12. See, did I switch the sign? Let me say this a better way. Did the sign have to flip to maintain the truth of the statement?
No.
No. But, all right, now let me do this in a different color. And let me do it over here. I'm going to do it over here. All right, so what if I have -1 and 3 again? So 3 is obviously bigger than -1. But now what if I come in with a purple freaking -4? That's supposed to be purple. I don't know. What if I multiply by -4? -4 times -1 is 4. 3 times -4 is -12. Which one's bigger now?
The 4.
Freaking 4 is bigger. Look what happened. All right, sorry. So why do we flip the sign when we multiply by a negative? Because that's how numbers work. When I multiply or divide by a negative, the one that was bigger is now the one that is smaller. They switch the sides they're on each other. So of course the relationship between the two switches. All right, I don't want to make this weirder than it is. It's just, that's it. So when do I switch the inequality symbol? When I multiply by a negative or divide by a negative. Okay. So how do I graph this thing? What symbol goes on the -12? You can use a couple things.
Just circle and you can go to the right.
I like it. So you can put a circle because they don't want to include the negative 12, right?
Yeah.
I don't want to shade up because that's the way the sucker is pointing. Or you could, of course, use a parenthesis if you want to. Okay, I like it. I like it. All right, I'm going to clear all this. Are you guys ready for that? I'm going to do it. Here it goes. Okay. Let's see what other weird shit they give me here. Oh yeah, we did this a little bit. Yeah, so we're good. All right, that's it. That's all I'm going to talk about. You guys got to get into section 3.4 and try it out so that you have some questions on that. Oh man, guess what we're getting into today? Oh man, I'm all excited. So you know it's going to be something gross. You ready? It's everybody's favorite thing. What's your favorite? And you know, I'm being sarcastic. So what is the least favorite thing for students in algebra? What is the number one hated thing? Does anyone have an opinion?
Word problems.
Yeah, that's what we're doing. We're doing word problems. And it's not Trisha's fault. Don't worry. We were going to do it even if she hadn't answered that question. Okay. All right. So I don't know why they have a word problem section and they put a SNEC. I don't know. It's up to them, I guess. But all right. So what I want to do is I desperately want to show you my whiteboard. No, I want to show you why word problems are the way they are. All right. This is so exciting. So stay with me. I understand that word problems are hated. I understand. I also understand why they're hated. I understand. I'm going to try to alleviate some of that hatred for these poor little inanimate ideas. So let's do this. Is that in focus? There's some beautiful trigonometry up there. I love it. Beautiful trig. Beautiful trig. Go with trig. All right, let me ask you guys. Let's see. How can I do this? Yeah, let's start off like that. So what if I said one number? Jeff, you could do it. Is 2 more than another? All right, so everybody with me so far. One number is 2 more than another, right? Do we know what either of the numbers are? If I just say this.
No.
Not yet.
Not yet. I love it. That's perfectly said. Not yet. What would somebody have to tell me? What's one piece of information somebody would have to give me, and then I would know both numbers?
At least one of the numbers, what they are.
In fact, I really need to know this number. I'm sorry, this number first, right? So I have one number and I have another number. So let me give us a couple of examples here. What if, the another number was 7? What if this one was 7? What would the one number be?
5.
No.
14.
9.
There it is. All right, so a couple things. 2 more than is +2. It's not twice. If I wanted twice, I would have said twice. Twice means multiplication. 2 more than means addition, right? If you have 2 more jelly beans than Frank, and Frank has 7 jelly beans, you got 9. You don't got 14, right? The other thing is, one number is 2 more than another. If the another is 7, the one is 2 more than that. All right. Is everybody with me so far? Is that like really crazy or what? You guys all right?
No, it's easy
So far.
so far.
But this is what word problems are based on, believe it or not. All right. What if the other number was 11? What would this number be?
13.
Holy shit. All right. Now, so that's a little what if. The reality is, reality comes in and says, no, you don't know shit. You don't know shit. We don't know shit. Were you guys paying attention? Which number did I have to pick first so I could figure out the other number? Not technically, but in this case, I'm going to kind of push this. I kind of had to tell you what this one was first, right? Do we know what this number is? Do we know what it actually is?
No.
No, we don't know what it specifically is, right? It could be anything. So I'm like, I have two numbers in my head and one of them is two more than the other. Do you know what either one is? You have no idea. It could be 7 and 9. It could be 11 and 13. Is my focus all freaky? Hold on. Oh, well, I'm not going to get it better, am I? Too bad. Too bad. All right. So I really want you guys with me. I can't say the other number is 7 because I don't know. I can't say it's 11 because I don't know. So what algebra does for us is it says, you're going to have to do some shit with this thing and you don't even know what it is. I have to do stuff to it. I got to add 2 to it. And I don't even know what it is. So it says, all right, calm down. Let's use a symbol to represent what it is. And of course, what's the symbol that we use for something that we don't know? What's the most basic symbol we use?
X.
X.
11. So if I call this one X, can somebody tell me what this one then would be? Don't say Y. It's not its own thing.
Z. No, I'm kidding.
When this was 7, what was this one? 9. How did you get 9? What did you do to 7 to get 9?
2 plus x.
Yes, or even a little bit better, x plus 2. This one is 2 more than this one. How long would it take you to list all the possible numbers these could be? How long would it take you to list everything it could be?
Forever.
Forever. Even more than forever. Look, my eye is still red. Shit. All right, anyway. Right? Forever. And then forever after that, and then forever after that. Are you guys all with me? Because it could be 7 or 8 or 9. What about 7.1876293333331? Could it be that? Yeah. Plus 2. Oh shit. All right. This is the quickest way to write all possibilities. Because what could X be? X could be 7. Okay, so this is 7 and 9. It captures that. X could be 11, so it captures that. X could be 3.7793, whatever the hell I said. So that's what algebra, and you're all like, ew, good job, algebra. Now watch this. What if I also tell you that these two numbers in my head add to be what, Jeff? I don't know, Jeff. What do you want from me? Let's say 28. So is 7 and 9 the right answer?
No.
No. Is 11 and 13 the right answer?
No.
Could you figure out the right answer without using algebra for this easy ass problem? Could you kind of keep going and just guess until you get the right answer? Do you understand what I'm saying? Could you? Didn't we get pretty close with 11 and 13? What do they add up to be?
24.
24. Do you think you could keep going and find the answer? Do you understand what I'm saying? Yes.
Yes.
Are you allowed to? No, you're not allowed to. You're right. So here's the thing. All right, guess what, guys? We're in an algebra class, right? So now listen. I always get at least one person that gets the answer not using algebra, and they're all like, oh, I got the answer. It doesn't matter how I did. So if you were, stay with me. This problem, by the way, this problem is stupid easy. I really want you guys to agree. You could get to the answer pretty quickly. It's crazy easy. You just can guess until you get there. We're almost there. But the whole point of this is to use algebra to get used to algebra, because not every problem is going to be this easy. So if you were in driver's ed, if you're learning how to drive a car, and your final exam was to drive to the mall, right? And you walk to the mall and you call your teachers, I'm at the mall, I made it. And the teacher's like, car's still here, what the hell? I walked. No, so should you pass driver's ed because you made it to the mall?
No.
Whoa. Yeah, no. Shit, no. Because the whole point is not to make it to the mall. The whole point is to learn how to drive to get to the mall. What if it took a bus? No. What if it took a train? No. What if you got a piggyback ride from somebody? No, you're not going to pass driver's. All right. So we're in an algebra class. If you don't use algebra to do these, you don't get credit. That should be very straightforward. So nobody come at me with, well, I got the answer. I don't care. The whole thing is about using algebra to get there. Okay, now, I've given us some new information about the two numbers. What are these two numbers supposed to do based on the new information? They're supposed to.
Would it be
Add
X?
it together to
Yeah.
get 28.
Now, Trisha's got the answer. Tell me, Trisha.
X plus 2.
Good. If I add the two numbers,
Equals 28.
I should get 28. That's why equations are the bread and butter of algebra. Because I can create an equation from information somebody gives me. Is that a hard equation to solve? Well, let me just say this. Solve that equation. I'll wait. Don't say anything yet.
Professor,
Yes.
why is it not just x plus x? Like, why is it x plus 2?
All right. Now tell me, what are the two numbers that we're working with?
I don't know yet.
You do. I want you. Here's what algebra does. We don't know, but then algebra says, pretend like you do. I know what the two numbers are. What are they? What are the two numbers I'm working with? What are the two numbers?
One or the other.
No, come on. What are the two numbers?
X plus x.
What's happening? What are the two numbers?
Oh, okay,
One of them
okay.
is x, and the other one is x plus 2. So when I add,
Two more.
I like it. If you wrote
Okay.
x plus x equals 28, that is assuming the two numbers are the same. Say one is x and the other one is x. They're the same. Can both numbers be the same in this problem? No.
No, okay, I get it.
I like it. You have to be able to find all the parts in your equation. There's one number, there's the other number. So what do you guys get when you solve this?
13.
Good. Is that the answer to the word problem? Do you circle this and keep going?
No.
No. How do you answer this word problem? You come back to this thing that you have definitely written for yourself because you're smart and you know that this will help you. This helps you set up the equation and it helps you answer the damn question, right? So how do I know I'm not done with the question? Because there's two things I got to figure out. I know what the other number is, don't I? I know it's 13. So then, of course, what's this one?
15.
15. Does that work? Does that work? Can you check the answer? What are they supposed to do?
Equal 28.
Equal 28. Do that?
Yes.
Yes, cool. See, you can see the answer. You can see if the answer makes sense. So again, any word problem, we identify what I call the players. What are the players in this problem? Two numbers. You call them exactly the same name that the problem calls them. The problem calls one number, okay, one number, another. We give them algebra names based on how they're related to each other, and then we set up an equation. I like it.
We can have other result than this one. Does it
No,
work?
nope,
No.
nope. Do you have a, well, I should have said this. Do you have another result?
If we made it in our head because it's easy, because just different two, that's why I just bring 28 divided by 2 is 14, and just take 2 from side and put it to other side. And in this case, 12, the first one is a 12 and the second one 16, and the total 28.
Stop. Are 12 and 16, do they match this requirement?
Oh no.
Nope.
Yeah.
How many numbers add to be 28? An infinite number of numbers add to be 28.
Okay.
Right?
I
But they
get
have
mine.
to do two things. They have to add to 28 and be 2 apart, right?
Okay. Thank you.
These are 4 apart. No good.
Okay.
I like it. Likey. All right, let's do another one. I can't stress enough how important this step is. I do have a handout that goes over the steps. If you follow the steps, you will make fewer mistakes, period. Those people that want to rush through it and get the answer quick, you're going to get the wrong answer really fast. So you're not wasting time, I guess. But I would not recommend that, right? I haven't activated it yet because I want you paying attention to this right now. Okay. Wonder handout powers activate. Not yet. So let's try another one. Let's do some geometry. Yeah, I've got a triangle. A triangle has a perimeter of, let's see. All right, I gotta make a problem. Hold on. Let me make a problem first. Do. All right. Has a perimeter of 12. The largest side is, one more than 3 times the smallest. The middle side is 4 less than. I'm sorry. Let me make this not too crazy. Yeah. Okay. 1 more than the smallest. Are you guys loving this? Yeah. Oh, this is awesome. Isn't this awesome? Sorry. All right. There's a lot going on here. Do you agree with me? There's kind of a lot going on here. Every math problem has a lot kind of going on. if you can break it down into which part do I have to focus on now, forget all the other shit, right? So let me actually put the question here. Find the lengths of all sides. Find the lengths of all the sides. Now, to be honest, I think I call it step 0. Step 0 is draw the picture, if there is one. Go ahead, Trisha, what's up?
No, I was just reading. I'm sorry.
Okay. Step 0 is kind of like draw the picture. Step 1 is identify the players. I have no idea if you're gonna like, I call them players. How many players are involved in this problem? How many parts are there to this problem? How many things are involved? How many physical things? Say again, sorry?
3.
3, and those would be the 3
Sides.
So what would you, so let's see. So we got the largest side. Largest side length. What else we got?
Smallest side.
Smallest. And we got the
And the middle.
middle. So I want to use the exact same language. So these are the players. The parts, the things involved. This, I'm glad nobody said anything about this yet. That's going to set up my equation because the perimeter talks about how all the sides interact with each other. Does that make sense? You guys remember what the word perimeter means, right? I think it's come up before, hasn't it? What's perimeter mean?
It's when you add up all the sides.
Add up all the sides. I love it. So that's going to be where the equation comes from. I like it. Now, here is the key question. The second step is, what am I going to call X? Which thing do I need to know first? There's a certain side that if I gave you its length, you could figure out the other two like that. Can anybody tell which side I should know first?
The smallest.
Why?
Because the largest is more than 3 times, and the middle is 1 more.
Yes, so the largest depends on the smallest, and the middle depends on the smallest. Do you guys see that? That is a key skill to have. What am I going to call just X? Well, you say to yourself, what does it seem like everything else depends on? What do I need to know first? So if I call the smallest side X, somebody else tell me, what can I call the largest side? How does it relate to that?
X times 3.
That's part of it. It's
3x.
Sorry?
3x, right?
Not quite.
X times
3 plus
3 plus 1.
Good. 3x plus 1. 1 more than 3 times the smallest. We stop. And I'm going to kind of, here's the smallest side. The largest side is 3x plus 1. I'm going to kind of label my picture as I go. Do you guys see that? 1 more than, add 1 to 3 times the smallest. Add 1 to 3 times x. Add 1 to 3 times x. Bam. I couldn't write that until I called this x. Now I can write that. What's the middle side going to be? That's nice.
X plus 1.
X plus 1.
Yeah, X plus 1.
Kick ass. And now, take a minute. Don't say anything. Try to set up the equation. I already told you that the equation's going to somehow come from that. Try to set up the equation. Don't say anything. All right. Who thinks they have the equation set up? Oh, I see something in the chat. I like that. I'm going to do it a little more. I'm going to flesh it out a little more. Perimeter means, like somebody said earlier, you add all the
Total.
sides.
The total, yes.
Sure. So I'm going to take this side plus this side plus this side. And then I have to get 12. So I have to be able to find all the sides because this problem is totaling up all the sides. How are we doing? You guys, how you doing out there, guys? You guys all right? Guys.
Yeah.
Okay. Okay, I like it. And now solve it. Don't say anything yet. Take a minute and solve it. Why is my, let me see if I can make this stop doing this. Let's see. There we go. So this needs to be, this one is not that horrible, right? So what do you guys get when you combine like terms here?
5x plus 2.
5x, good, because 3x, 4x, 5x, and 112 equals 12. I like it. And what do you do?
-2.
Good. Subtract 2 so I can get the thing with x in it by itself. 5x is 10. And then, of course, the last step.
Divided by.
Almost always divide last. So I get x equals
2.
Do I circle that and keep going? You know the answer to that is
No.
no. Jeff. All right, let me put one more thing in here because you know this is going to become a part of this. I should have put this in at the beginning. You ready? Make this 12 feet. You know there's going to be units. So if there are units in the problem, your answer has to have units. Now watch this. Since we did this, and it wants to know the lengths of all sides, this is easy now. So here's how I put my answer. The smallest length is 2 what? It's really easy now that I just did it, yeah. 2 feet. So what's the largest side? If x is 2.
7 feet.
Good, 7 feet. Is everybody with me on that? It's 3 times x, but we know x is 2. And then what's the middle length?
3.
3 feet. Does that check? Does that work? What are these supposed to do?
Add to 12.
And they do. Yay! Right? It's always nice when you get to the end and it does everything it's supposed to. It's like, oh, thank God. All right, so let me show you this handout that I promised. Let me make it active on the canvas. Such a yummy problem. Okay, sorry. I'll stop being all creepy. Try to keep that up there for a minute. So let me activate this. Hold on. Activate on the canvas. It's gonna take me a minute. Do. Bam. All right. So now if you go to canvas, let me show you where it is. Here, let me become a student. Go down to unit 3. It says word problems. Nice and to the point. Open. There we go. Look at that. Oh, it's so yummy. There's a problem. Is that almost, that's almost the same one we just did. There's another example of a triangle. It shows you all the steps. What are the players? Which one is just X? Draw the picture if it makes sense. Translate from English to Mathish. That was this step here, setting up the equation. Solve it. Give the complete answer. Check it. I like it. And then they give you another example and another situation. So let's do this. Let's see. I want you guys to try out. Let's see. These first two are kind of weird, I think. Well, let's see. Can you try out number 1? I like number 1 and 2. I call those pseudo equations. They're like somebody reading an equation to me. So they're not like real word problems. I don't know if you guys agree with me. It's if somebody just read to me what an equation said, they could say a number divided by 3 equals the number decrease. So they're kind of like reading the equation to me. So you just have to write the equation that they're reading off to me. Does that make sense? Number 3 is kind of like the first real word problem here. But try number 1 real quick. And then we'll try number, let's see. Let's do something different. Oh yeah, we'll try number 4. Yeah, I like it. Uh-oh, somebody's chatting at me. Oh, sweet. Okay. Thank you. So again, number 1 is a little different. It's much more direct. I really don't have to set it up as much because there's only one player, the number. So help me out. All you got to do is pick, what do you want to call the number? What symbol do you want to give it since you don't know what it is?
X.
Sure. And to be really honest, you could use any symbol you want to. You could use Y, you could use Z, you could use pi, you could use happy face, you could use a star. It doesn't matter. It's just a symbol that represents something I don't know. So the most commonly used one is X. So a number divided by 3. So how do I write that? Since we picked what the number is.
X divided by 3.
So X divided by 3. This is pretty straightforward.
Equals
And then what is this?
X minus 10.
Good. I like it. All right. Now, this is a deceptively, I don't know what to term this. It's easier than it looks. It actually looks easy and then it looks hard. It's a little tiny equation, but it kind of freaks people out. What's the worst part of this equation? What do you wish wasn't the way it was?
The fraction.
Fraction. So the great, beautiful thing about equations is most of the time, if there's something in it you don't like, you can kill it. Again, this is a math lesson, not a life lesson. All right. So I don't like the fraction. So what do I do to kill it?
Multiply by 3.
Yeah, because right now it's X divided by 3. So let me multiply both sides by 3. All right, so then what do I get? So I get X equals, what do I get on this side?
3x minus 30.
Good. So let me write that up here so I got some more room. All right, so now it's up to you. But there's one quick way. What's the only thing that's in the wrong place, the way it's written so far?
The 3.
The 3x.
Yeah.
Okay. So how do you get that out of there? How do you kill it?
Divide the 3 by negative 30.
Whoa. No. So I agree with you. So let me get this rewritten better. Hold on. I agree with you. The 3x. Does everybody... The 3x is definitely in the wrong place. How do I know? Because all the numbers are together, but the x's aren't together. So this guy's in the wrong place.
We have to divide it by 3.
No.
Oh no, oh,
Minus
sorry,
3x.
negative 3. Negative
Minus
3.
3x.
So yeah, you have to subtract,
Distract it, yeah, negative 3.
yes. Because whatever we do, we have to make sure that what we do actually cancels the thing I want to cancel, right? So what do I get on this side? X minus 3x.
Minus 2x.
Minus 2x. Then I have an equal sign.
Minus 30.
And what's the last thing I do?
Divided by minus 2.
Divided by negative 2. So I get x equals 15. And now in this case, why am I done? Why can I circle that and just keep going? Because that's all I wanted to know is what's the number. So let's check it. If the number is 15, what do you get when you divide that by 3?
5.
5. And what do you get when you decrease 15 by 10?
5.
Yeah, you get the same thing. Yay! So that number does what it's supposed to do. All right, now. So number 1 and number 2 are very similar. They're kind of like just somebody reading an equation, and then I just have to write the equation and then solve it. So that's not even what I would call a real word problem, to be honest. Let's try does everybody have this? I should have opened this a different way, but oh well. I'm gonna have to erase this. You guys ready? I'm gonna erase it. Okay, here it goes. It is now gone. Let's look at number 4. So try out number 4. Oh, I forgot I had more down here. Yummy. I mean, oh well, I've already said it. Number 4. I'm so creepy. Ooh, yummy math problem. Yummy. This one's a little bit, you got to be careful. I highly recommend you draw the picture. Yeah, I didn't really do this well, did I? But oh well. We're going to assume he's going to fence in the whole thing, right? Even the side next to the house. So just let me help out. So here's the picture. Oh boy. Pretend like that's a rectangle. Hold on. I can do better. Oh, Jeebus. Almost, Jeff. Oh well. Can't even do it with the computer's help. Jeez. Can somebody tell me how many players are there in this problem? How many parts? How many things?
Technically 4.
Okay. I see what you mean. But in reality, there's how many things?
2.
2. What are they?
The length of the longest side and the length of or the width of the other side.
So the length and the width. I like it. Now, somebody else tell me, which one am I going to call a variable? Which one am I going to give a letter to?
Wide.
Yeah, why the width?
The width.
Why the width?
Because it says 4 meters longer than it is wide.
Good. So if I knew how wide it was, then I could figure out how long it is. So I'm going to be some kind of smart here. I'm not going to call this X. I'm going to call this W. Ooh, look at me go. So I could use whatever letter I want to. I could use a letter that relates to the problem, which is helpful. Now, if I call the width W, I'm not going to call the length L, because the length can't be anything it wants to be. If the width is W, what must the length be?
W plus 4.
Good. W plus 4, not 4 times W. It didn't say 4 times longer. It just said 4 meters longer. Now here's where you desperately need to label the picture. So now I know the perimeter. Well, do I know the perimeter? What's the perimeter going to be? Do I tell you what the perimeter is?
What is it? W plus
Okay.
W plus 4 plus W plus 4.
Almost. That's 1, 2, 3 sides.
Plus
One more
7.
W.
Yeah.
One more W, yeah.
I might have said that, but I might have got lost in there. Okay.
Equal 92.
So now I got 1, 2, 3, 4 sides. And good, that's the perimeter. They have to equal the 92 meters of fencing. And now you just solve. So the hardest part of a word problem should be setting up the equation. And then when you go to solve it, that should be the relatively easier part. But what made this problem easier? I drew the picture for myself. When I identified the parts, I labeled the picture with those parts. The biggest mistake I see on this kind of problem is somebody looks at this, they don't write any of this down. They say, oh, 4 longer than the width equals 92. There we go. That is very obviously wrong. You guys agree with me? So if I want to put my pet pot-bellied pig back here, here she is. Oh my God. She's a mutant pot-bellied pig. I really want you guys with me. If I use this equation, that means I am only fencing in one side, which means my pot-bellied pig pet ain't gonna stay. She's gonna walk away. She's gonna be like, you're nice and all, but I gotta see the world. And she's just gonna wee-haw. So I gotta close in all of the sides. I need all of the sides in here. Okay, hopefully, I don't know if that made any sense. So what are we getting for this, for solving this? What do I get when I get my like terms together?
4W
4W plus
plus 8
8.
equal 92.
And so this is not too bad, right? Subtract
Yeah.
8. And then
Divided by 4.
divided by 4.
W 21, I think.
Yep.
Yeah.
21. So the width is 21 what?
21 meters.
Good. The length then has to be
25.
25. You just add 4 to the width. Now, if we check this, if I had 21, 25, 21, 25, that adds up to be 50 and 42, which adds up to be 92. Yay, 92. So it works. All right. Okay, all right. So the steps you don't want to skip. Identify the players for sure. Give them variable names. Draw a picture if it makes sense to draw a picture, especially for geometrical problems like a triangle or a square or something. Set up the equation, solve it, make sure you answer everything. Right? And of course, I capture all of those steps at the top of this handout. Is everybody ready for me? Can I delete this? You guys ready? Does everybody have what they need from this? All right, here it goes. Bam. So up here is 2 examples with all the steps. 2 examples with all the steps. Why didn't I draw a picture here? I could draw a little man and a little woman, but that's not going to help. So I didn't draw a picture. This one, picture helps.
Yes.
All right. So not horrible, right? Is that not as horrible as you remember word problems being? They're not that bad.
No, it's not too bad.
Oh, that was okay.
All right. You don't have to say that if you don't believe it, but obviously they're going to get a little bit harder, but they never like go away from this idea of how to set it up. If you always stick to these steps, you can tackle the problem no matter how gross it gets. Okay, I think that's, oh, somebody chatted at me. 92 minus 8m divided by 4. I'm not sure, wait a minute. I wish I would have done that earlier. So 92 minus 8. Oh, I see. Well, if you set up the equation, you can do that. Sure. But that better not come out of nowhere at me, right? You have to have the equation set up, Trish. Okay, I think that's enough for today. What do you guys think? Anybody upset? You know, like, I want more math class, Jeff. All right. I'm sorry if you feel that way. We're going to end. So you're free to go. Let me know if you need to hang out afterwards, if you have any question.
Thank you, sir.
Well,
We have class tomorrow?
no class tomorrow.
No, okay, thank you.
All right, thank you, Professor. Have a good
Well,
one.
see you. Everybody good?
Thank you so much. I'll see you next week.
All right.
Yeah, no, I set up the equation backwards.
Backwards, how do you mean?
So whereas you had it 4w plus 8 equals 92, I had it as w equals 92 minus 8 divided by 4.
But how did you get there?
Well, I drew my little diagram thingy.
Okay.
So you divide it by the 4 sides and you started out with like the 92. So the 1w side.
All right, hold on. So I really need to understand. So you have this, and then what'd you put on it?
So I have w on each of the shorter sides. And then I have the w plus 4m and the w plus 4m. And then I have the equals 92 next to it. And then I just worked backwards from there.
So in your head, you sort of have this.
Kind of.
So it's better to write this. Yeah, trust me. Makes it easier for me to grade, and the problems get a little bit harder. And the harder they get, the harder it is to keep in your head what the equation is.
Okay.
Yeah. Okay. So I get what you're doing. Yeah, you had this in your head, and then you sort of did a little bit of the algebra in your head, but that makes it hard for me to grade because it can't get in your head.
Well, so I worked from the 92m and I subtracted like the 8.
Sure.
And then I divided it by the 4 sides.
But you kind of went from here to this, is what you're saying?
Yes.
See, that's a big jump for me. So there's too much happening in your head. I can't see. So if you make a mistake, I'm not going to know. It's not going to be easy for me to tell where the mistake happened. Yeah. Because I don't have a lot to work with. Yeah. So, I mean, technically there's nothing wrong with that. If you were working it out somewhere and it wasn't a graded thing, you're out on the field and you're doing something, you know, in your job, who gives a shit, right? You can do that. But I have to grade stuff, so I don't know. I couldn't do it.
Okay, thank you, Professor.
Sure. All right, everybody else okay?
I have a question for your 160 class, because I know you mentioned before that we'll be returning back during summer. Does
Yes.
that mean all of your classes would it be hybrid, or do we go to class like all of the days?
To be very honest, they have not yet given me anything specific about how it's going to work.
Okay.
It's really annoying to me because I feel really bad, because as the teacher, I feel like I should always know how my class is going to work. And it's really frustrating for me that they still have not told us exactly how this is going to work. I'm pretty sure that we'll end up like a normal on-campus class, but we're all going to be masked up. I'm going to try to get a face mask because they're telling me I'm going to have to be masked up, even though I'm not going to be anywhere near the students. But beyond that, I have no idea how it's going to work. I don't even know if all the services are going to be available on campus as normal. So yeah. So
okay, and then one more question. When does your math class end? Because I checked and it says the 22nd.
yeah, July, is it July 22nd, I think, right?
Yeah, because on a different thing it says that usually classes end around August 5th.
Oh,
But is that just an estimate?
so that's, I don't know where that came from, but we used to have like 4-week, 6-week, 8-week sessions just to make it easier with all the restrictions. They're making everything have a 6-week session.
Oh, okay.
Normally the 8-week sessions would end in early August, but now everybody's ending in late July. Yeah.
Okay. Thank you.
You're welcome. All right, Daniela, you good? Okay, I'm out of here.